So core practical for respiration rate. So in this core practical, if you see, they have made this device. Okay, they have, this is the setup, experimental setup. You can see in this setup, they have what? They have a scale, they have a capillary tube, they have this cork is there, correct? And they have this test tube. In this test tube, they have a cotton wool, correct? And down you have what? A soda lime is there. Sometimes they put a kind of, there is a term that we use, wire, I don't know how you pronounce this thing.
Oh, yes.
Wire gauze or gauze. How you pronounce, by the way, this part? G-A-U-Z-E. I call it wire gauze. Yes. So it is actually, it is having a small kind of holes in it. Yes. So we are keeping a small animals here. Like normally, this small animals, normally they are maggots or ants. Correct?
What are they?
Maggots, M-A-G-G-O-T, maggots.
Oh, yes.
Or ants you have to take. Small
Yes.
animal you have to take. Now, what is the basic principle? All of this is filled, this capillary tube is filled with a colored liquid, okay?
Yes.
This soda lime which is there inside here, this soda lime has the ability to absorb carbon dioxide. Already, I think somewhere we discussed this part.
Yes.
Maybe with you or someone else. Okay, so this soda lime is actually responsible to absorb carbon dioxide. So for example, in this test tube, there was carbon dioxide. It was absorbed by this soda lime, correct?
Yes.
Moreover, once these small organism, ants or maggots, once they will respire, they will be producing what? Carbon dioxide. So this carbon dioxide which is produced by the maggot, again it will be absorbed by the soda lime. Correct?
Yes.
One. So now exactly what is the basis of this practical? Here these small organisms, once they will start respiring, they will be start using up oxygen which is present in this test tube.
Yes.
Okay, once they will start using up the oxygen, so what will happen? This colored liquid, it start to move in this direction. Why?
Yes.
Because the pressure, because oxygen is being used up here. So here the pressure decreases. So this liquid start to move in this direction.
Yes.
Got my point?
Yes.
Faster this drop or liquid move this way, faster is the rate of reaction. Lower this liquid move in this direction, lower is the rate of respiration.
Yes. Yes.
You got it?
So, sir, what about the cotton wool?
Sorry?
What about the cotton wool?
Cotton wool is actually acting as a separator, because it look this cotton wool, so what it will do, like the oxygen or carbon dioxide which is here, so it is actually, the wire gas is there, yes?
Yes.
So it is actually acting as a platform. It is acting as a platform to keep the maggots or ants on top so they don't fall into this liquid. So they are acting as a separator.
Okay, yes.
You got my point. And moreover, this cotton wool is actually porous. Porous means oxygen and even liquid can easily move through. Yes.
Yes.
So the carbon dioxide which is produced by this respiring small organism. So this carbon dioxide will go down into this soda lime and it will absorb. So why? If this carbon dioxide which is absorbed by this small organism, which is produced by this small organism, if it is not absorbed by the soda lime, what will happen? It will rise and it will make this, it will influence our experiment setup.
Yes. Sir, I did not get that point.
Again, there are two ways of getting this thing. Different people, they will be doing in different way. This experiment depends upon how you are going to conduct and how are you going to explain. There are different ways of explaining this part.
Yes.
Look here, these small organisms are there. They are respiring organism, correct?
Yes.
What is the role of this soda lime? Absorbing carbon dioxide,
Yes.
correct? This soda
Yes.
lime will absorb carbon dioxide. Whatever, once, for example, you have a bunk, yes?
Yes.
We are separating, no more oxygen or air can come from outside, correct? It is airtight. So whatever
Yes.
the oxygen is available, it is available in this test tube only, correct?
Yes.
The whatever the carbon dioxide which was there in this test tube, it was absorbed by the soda lime, correct?
Correct.
Okay, next you have a small organism, small organisms. Why we are using the small organisms? Because they will be respiring at lower rate. They need less amount of oxygen. So in this test tube, we have very limited supply of oxygen. So if they are the large animals, so they will die.
Yes.
Correct? This is first thing why we are using. If you are using a large animal here, then you have to make a large container.
Yes.
Correct, maybe you can put a rat or mouse or some other larger organism. Sometimes we can put here germinating seeds also, but even germinating seed also, if you put here, this is not sufficient because they respire at very high rate. So that is why we are opting to use small organisms, correct?
Correct.
So in this way, we can manage with this experiment. We can manage with this experiment. Okay. Now, the point that you are struggling with, what exactly is happening in this test tube? Carbon dioxide was there already before it was absorbed by the soda lime. So which gas is now remaining here? Oxygen and nitrogen.
Okay.
Obviously, if we go for the percentage of air composition, 78% is nitrogen, 21% is oxygen, and 0.03% is remaining. 0.03% is what? Carbon dioxide. Isn't it? Composition of air. So that carbon dioxide will go down. It will be absorbed in the soda lime. Correct?
Yes.
Okay. Now, what next? Next will be whatever the oxygen. So here we have oxygen and nitrogen. Yes.
Yes.
Once this oxygen will be started to used up, it will start to deplete. Why? Because this respiring small organisms, they will start to use oxygen which is present here. Once they will be respiring aerobically or anaerobically.
Anaerobic. Uh,
Sorry, they will be respiring aerobically. Why? Because already this small oxygen is already there in this test tube. Get this
okay.
concept.
Yes.
Now you got it. There is
Yeah.
already oxygen here in this. Once we put this bung on top of this test tube, so the air which is there inside this test tube, this air contains already oxygen.
Okay. Yes.
This oxygen will be used up by these small organisms. So obviously they will be respiring aerobically.
Yes.
What we are trying to use here, we want, like, once they will be respiring aerobically, they will use up oxygen. Once they will, before, how, which gases are there on this area, in this area, which two gases are there? Oxygen, nitrogen. Yes,
Yes.
because carbon dioxide was absorbed by this soda
Uh,
lime.
to the left. Yes.
Correct. Now
Yes.
once these small organisms, they will start respiring, oxygen will start to deplete. Once this oxygen will start to deplete, there will be these small organisms, due to respiration, obviously they will be again producing the carbon dioxide, correct?
Yes.
This carbon dioxide which will be produced, again this will go down into the soda lime. This soda lime will absorb the carbon dioxide.
Okay. Yes.
There are different ways. Okay, I will explain this thing, the other way also I will be explaining it to you. Okay.
Yes, please.
Okay, now once this oxygen is depleting, so here the air pressure will decrease here, correct? Once the air pressure will decrease, this is because of oxygen is being eliminated. So here
Yes.
the pressure, once this side the pressure will decrease, so this colored liquid, it will start to move in this direction.
Okay. Yes.
Faster it moves mean faster is the rate of respiration. Slowly it's move means it is rate of respiration is very less. Correct? Obviously, once the respiration rate will be lower, this liquid in this direction, if it is moving, it will be moving slowly. And if the respiration rate is more, it will be moving faster in per unit time. Anytime you can decide 2 minutes, 10 minutes, 15 minutes. Correct? So the
Yes.
distance traveled by this color liquid, it will it will determine whether the rate of respiration is faster or slower.
Yes.
You got this concept?
I did.
Yes?
Yes. Sir,
Okay.
is there specific calculations to do?
Yeah, there can be specific calculation. For example, they ask you, for example, this thing they are making. Yeah, correct. So there are two variables you can go for. So here will be time, yes, and
Yeah.
here it will be distance traveled, yes, by the
Yes.
liquid. So maybe in 1 minute, how much distance is traveled? 2 minutes, how much distance is traveled? 3 minutes. This time interval is your choice. So this is controlled, or this is, if sorry, this is independent variable.
Okay.
Distance
Yeah.
travel is dependent variable. So once you'll be making this thing, so distance will be at y-axis. Correct? Yes or no?
Yes.
Time will be on x-axis and distance will be on y-axis.
Okay. Yes.
This is first thing. Now, the point is here, this is one way of getting the calculations, correct? Depending. The second
Yeah.
way can be you have fixed already the distance. For example, from here to here, there is 2 centimeter distance. This bubble move or this liquid move from here to this direction in how much time? Distance you have fixed 2 meter distance or 2 centimeter distance is traveled. Now, if the
Yeah.
distance is fixed, how long it takes to reach to from here to here, then the time is now dependent variable. Distance will be independent. It depends upon the question. Got my point?
Yes.
If you fix the distance, then you will be, if the rate of respiration, if it is traveling in 2 minutes this time, and another experiment, it is finishing in 1.5 minutes, yes? So in
Yeah.
1.5 minutes, rate of respiration is higher. In 2 minutes, rate of respiration is slower. It
Mm,
depends how you are convening your experiment, conducting your experiment.
okay. Yes.
Correct? It is total your choice. Okay, then for example, if you can control the temperature here, you put this into the water bath. Okay, for example, this whole setup you put into the water bath. Okay,
Yes.
here the temperature of the water is 20 degrees Celsius, then it is 30, then it is 35, then it is 40 accordingly. So now you brought temperature into the context. So at different temperature, rate of respiration will be different, right? Distance at this temperature, the distance travel is this. At this temperature, the distance travel is. So effect of temperature on rate of respiration. Again, this depends upon your setup of experiment, how you are setting up your experiment.
Yes.
Any problem?
No.
Now, what will be, for example, in this setup, what I told you, what is the control variable? Couple of control variable, you tell me. If you are conducting this experiment, what will be the controlled variables? Dependent and independent, already you know, yes? For example, time and distance.
Yes.
Okay, tell me the control variables.
Um, the amount of organism, small
Yeah, Shabash,
organism.
number of organism, not amount of organism, number of organism. For
Yeah.
example, you are using 3 ants Type of organism also controlled. Like you cannot do in one you are using ant and the other setup you are using maggots.
Yes.
Type and number of organisms. One. Age of the organisms also. Like in one test tube you are using the organism of lower age and other you are using the old organisms. Yes,
Yes.
because younger organism their rate of respiration is higher, correct? So what you can do, how you can modify this thing, you can use the same organism. For example, three ants are there, same ants you use throughout the experiment,
Okay. Yes.
correct? For
Mm.
a different reason, yes, at different setup like temperatures that you are saying, correct?
Correct.
Okay, type, size, number of the organisms, correct? This can be three, yes. What will be next control variable?
Temperature?
No, temperature. For example, if it depends upon the question. If they phrase the question like, at which temperature the rate of respiration is higher and lower, then obviously you have nothing to do with this temperature, correct?
Yes.
Yes. But anyway, amount of soda lime,
Oh, yes. Yes.
correct? Third, same apparatus. It cannot be used like in this, the apparatus, the capillary tube is smaller and the other experiment you are using a capillary tube with different diameter.
Yes.
You
Okay.
can justify, isn't it?
Yes.
Risk and management, what can be the risks here?
Uh, ants bite you.
And bite, very good, very nice, good. So this is the risk. How you can avoid it?
Wear gloves.
Gloves, very
Yeah.
good. Okay, next, second risk.
Sir, soda lime.
Soda lime, a chemical. So it is a chemical, obviously, yes.
Yes.
So this is a risk. It can be causing some kind of allergic reaction or different kind of harm to the skin. Yes, again the same thing. Third, glassware, broken
Yeah.
and blah blah. Yes, if
Yes.
this is related to the temperature control and all, you are using the water bath, so obviously this is a big hazard. Yes, so you can use like in the water bath, once you are done, you have to keep this thing in the center of the table, blah blah blah, correct? Once you are done with the experiment, turn off the Bunsen burner, blah,
Yes.
all these things you can just, then obviously now you understood all this.
Yes.
I'm giving different twist to this experiment now, okay?
Okay.
By using small organisms, you got it like what is happening? They are respiring aerobically, correct? It is obvious.
Yes.
Any problem?
No.
Okay. Now, let's say if the same experiment is there, okay?
Yes.
If I use, instead of small organism, if I use yeast here, what will happen?
State of small organisms. What will happen?
Look, interestingly, this is not a part of the question, okay?
Yes.
This is not a part of question. I'm just giving you a, if the same apparatus we are using and we have changed the organism here, we are putting in what? Yeast. Once the
Yes.
yeast is respiring aerobically, yes,
Yes.
this color liquid will start to move this way. Obviously,
Yes.
once this yeast will start to respire anaerobically, this color liquid will start to move in this direction because there is a capacity of soda lime to absorb carbon dioxide, correct?
Yes.
Once this capacity is saturated, so obviously no more carbon dioxide can be absorbed. So this carbon dioxide will start to rise in this. There was already the oxygen is being used up, correct? Now this carbon dioxide, once these yeast, they will start respiring anaerobically. So the carbon dioxide will be produced. Yes, this carbon dioxide will start to rise, and then this bubble, colored bubble, it will start to move in this direction. Did you understand?
Yes.
So if the bubble is moving this direction, yeast is moving aerobically, and if the bubble start move this way, now the yeast is respiring anaerobically. You got my point? The same apparatus.
Okay.
Any problem?
Yes, sir. No.
Yeah. So now in the same way, you can modify the experiment and you can say like you have to repeat the experiment different. So actually they are talking about different temperatures. So obviously you have to use water bath. So according to the question, you have, they are talking bath at an angle. The angle should also be the same. This is very important. Like, you know what I mean? It should not be tilted. In one test tube, you are putting it at tilted form, and other test tube, you are putting it at this. So once you are conducting the experiment, the angle. So this is a control variable.
Sir, why does it matter?
You know what I mean? Obviously, if it is tilted, so this area, you know what I mean? I think it will matter to some. Look here, the place both test tube into the rack into the water bath at set temperature. It is best to tilt the rack slightly so that the capillary tube hang over the side of the water bath at an angle. So it will actually, this tilting will facilitate this one. Look here, if it is straight, yes, there is a chance. This is to facilitate this water which is present inside this liquid, controlling the movement of this colored liquid,
Um,
controlling the movement of this colored liquid. Okay, I will tell you. For example, shall I give you a little bit more? Look,
yeah.
if I tilt it in this way, the apparatus is tilted in this way, little bit tilt. So now it is the capillary tube angle is this now, okay? Not straight one. It is like this.
Okay.
What is the advantage? There is more pressure on water to move in this direction, correct?
Yes.
Once this oxygen will be depleted, so it can easily move down. But if it is straight, or it is moving this way, the tilt is this way, maybe, okay, there is a depletion, but there is not enough pressure to rise, make this water move. Got my point?
Yes.
Yes, that is the point.
Okay. Yes.
Okay, so you can just jingle with this experiment according to your need.
Sir?
Yep. And one more thing, after repeat, you have to go for graphical explanation also. Yes, I will be plotting a graph at different temperature and comparison. Yes, now you can ask me a question.
Sir, how does temperature affect respiration?
Rate of, if the temperature is higher, enzyme, they will be better. Related with the enzyme activity, respiratory enzymes are there, yes?
Yes.
So that is why at lower temperature, our respiration rate is lower. At high temperature, respiration rate is higher.
Yes.
You understand? So you can directly link it with the enzymes which are controlling rate of respiration.
Okay. Yes.
Any problem?
No.
We are done with this core practical, okay? So we discussed all the aspects of this core practical, okay?
Yes.
Okay, now the next thing is, we are moving to the next now. So here, look here, the temperature they have given, yes?
Yes.
Better you try it by yourself, okay?
Okay, sir. Sir, can I try the answers and send it to you?
Yes, obviously you are more appreciated if you do like this.
Okay.
Okay, then we are saving time actually, correct?
Yes.
Yeah. Okay, next is you know this all of these things, correct? Have you
Yes.
started this topic in school?
Yes.
Okay, just a minute. First of all, you know what I mean? I forgot to do one thing. You know, this before we start with the ecosystem, I will be just stopping this recording.